Hello, I'm Ward Ramsdell, and I'm an electronic design engineer with Prototype Engineering. Today we're going to be looking at the MDO4000 in the context of some personal activity sensors, one of the products that we worked on. These are very small sensors meant to be integrated into various things that might be worn on the body or be part of your daily lifestyle. They're on a very thin, capped-on substrate, small integrated antennas, and on the substrate is a microcontroller, 900 megahertz radio, and an accelerometer. And so as you go about your daily activities, this is monitoring activity. It's not monitoring position, but merely the amount that it's being moved around. And then that is communicated back to a gateway device periodically, which then transfers the data to a server and makes it available via the web. A couple of different form factors here. There's a small one with an associated small lithium battery. There's also a larger one, which is what we'll be looking at today with the MDO4000 on a much larger substrate, more the size of a business card with a printed antenna. And so to this one I've affixed an RF coaxial probe and a couple of test points. And we're going to connect this to the MDO4000 and capture the first packet that it transmits. So it's a transient event that we're going to be capturing, and we'll analyze it offline. So now I've moved the sensor over to my bench and I've attached it to a power supply into the MDO4000. The MDO4000 is connected to the RF output of the sensor, and the power supply is connected to the main supply leads. What I'm going to do is I'm going to, with a single trace capture, grab an entire packet from the sensor and look at that in detail, analyze it for the preamble, the packet body, and also the turn-on of the packet. The triggering method that I'm using is an RF trigger. So really I'm doing everything in the RF domain here. It's an RF power level trigger, and it picks up on the beginning of the packet, which is a very strong rising edge. So I'll set the oscilloscope to the single trace mode, turn on my power supply, which will trigger that first packet. The scope's triggered at this point and it's gathering data. And now what I'm able to do is navigate through the time record using the pan knob. Now you can always see what you're looking at in your spectrum display by looking at the spectrum time bar at the bottom of the top display. So now I'm looking at the rising edge of the packet, the turn-on characteristics of the sensor. Here's the preamble. You can see that it's a series of tones that's being generated as a preamble, and then we get into the packet data, the body of the packet. And all of this is done with the instrument stopped. I've done a single acquisition of the very first packet that's transmitted, and that's the entirety of the data acquisition that I've done. Everything else here is completely offline, just navigating using the pan knob, which is a very simple, intuitive way to look at things. And so I'm coursing through the time record here and able to look at events happening throughout the body of the packet. So what we've shown in this example is the ability of the MDO4000 series to capture with a single trigger event a large quantity of data, in this case 40 milliseconds worth of a packet from a small embedded transmitter. I was able to analyze that data offline, navigate through the time record using the pan knob in a very simple and intuitive manner, and I was able to look at the period just prior to the packet preamble, and the packet body of data, all with a single capture.